stacking factor means you can see that transformer is made up of thin lamination sheet. If you see this figure, you have a different core. You have a core here. You have anything but what thin lamination sheet. Likewise, we have 50. You have 100 types of lamination sheet, and it is munched together to form a core. Okay. For each lamination sheet, they are going to do what? They are going to do the insulation. Insulation is nothing but what? They usually spray the varnish for front side and for both the side. For each thin lamination, they are going for insulation of by spray of varnish. Likewise, if all the thin laminations stacked together, then definitely the gross area of the core will increase. It along with the iron part, even the insulation part will also include. So the gross core section AGI is nothing but what? Your net iron core AI into the stacking factor. Okay, so the net iron core AI is equal to what? KS into AGI. So AGI is something about the gross core area. This is a core here. You can see here. These lines are called as each lamination stacked together. So each thin lamination will be what? Will be insulated by usually spray of varnish. If they stack together, definitely the net iron area AI. Net iron area AI definitely. Net iron area is nothing but what? KS into AGI. And AGI is nothing but the gross core area. The gross core area includes what? Includes both the iron part and even the insulation part. Okay. So if I want to calculate only the net iron area, only the iron part, then that is equal to what? KS into AGI. Where KS is called what? KS is called as a stacking factor. And usually the stacking factor will be around 0.85 to 0.9. Okay, usually 0.8 to 0.9. And if you multiply here 0.9 into AGI, so 0.9 corresponds to what? 0.9 corresponds to the 10% is used for what? Is used for insulation. If you multiply AGI into 0.9, that will give only the net iron area. Another 10% here, you can say another 10% is for insulation. Okay, is for insulation. This is regarding what the stacking factor. So stacking factor is lies between 0.85 to 0.9. Normally, the gross core area will be greater compared to the net iron area because the gross core area includes even the insulation. So, with respect to the transformer, just we will do some analysis of what we have different types of cores like a square core, a cruciform core, or two-stepped core, or three-stepped core, or four-stepped core. So for here, we'll do analysis for two types of core. We'll take up a square section and we'll take up a cruciform or two-stepped core section. Likewise, you can do for three-stepped core and you can do for four-stepped core. Now, design of core. We're going to design of core. We're going to take this square section. You can see here. This is the square section. You can take a square section means what? Both the width and the depth of the core will be what? Width and the depth of the core will be same. Means both sides will be same. If you go back to the figure here, okay. You go back to the figure. See here, both your width and depth. Depth is nothing but you are going to place the stacking of the lamination. Okay, your width and depth. With respect to the core, we are talking in two terms. Nothing but only the width. We don't talk about the length. Definitely, your width and the depth of your thin laminations. Okay, so both will be same. A into A. Okay. Now D. Let us give D is something but what? D is something but nothing but the circumferring circle. D is something but diameter of circumferring circle. Okay. If you take this rectangle triangle here, you can see here this is a rectangle triangle. If you take D, is something but you can use the Pythagoras theorem here under the root of a square plus a square, 2a square, and a into root 2, and a is equal to what? D by root 2, 0.70 D. Where a is what? A is the side of the square. We have two sides here, width and the depth of your core. Okay, side of the square, and D is something but what? Diameter of your circumferring circle. The gross core area AGI. The gross core area AGI, once again I'm telling you, gross core area AGI includes, along with this lamination, along with the thin lamination, it includes what? It includes the insulation part. Insulation part is nothing but it is a spray of varnish. So AGI is equal to what? A square. AGI is equal to what? A into A. Gross core area. Gross core area. A into A square. So A square is equal to what? D by root 2. What is A? A is something what? D by root 2. Then what we got? AGI. AG is equal to what? 0.5 D square. Now let us calculate the net terrain area. Net terrain area A is nothing but what? Ks into AGI. So Ks, what is Ks? Ks is between 0.85 to 0.9. You put 0.9. So 0.9 into 0.5 D square. So if you multiply here, what you get here? 0.45 D square. Okay, if you go through this AI is equal to 0.45 D square, and here go to 0.5 D square. You can see here that the AGI, the area of AGI is more compared to the net terrain area. Okay, since you have taken here 50%, definitely here it will be what? 0.45. 5% is for insulation. Like if you go for 100%, then 10% accounts for what? Accounts for insulation. You can see here if AJ is equal to 0.5 D square and AI net area, you can say 0.45. Another here 0.05% will be what? Will be for insulation. Okay. Next, you can calculate the ratio. Ratio net core area AI divided by area of circumscribing circle. Nothing but what? Net core area AI. A is what? 0.45 D square divided by area of circumscribing circle, pi r square. Okay, pi r square, 0.45 D square. R is something but what? D by 2. Okay, radius is something but D by 2. So pi D square by 4. If you solve this one, what you get? 0.58. That is one ratio. Second ratio, gross core area AGI divided by area of circumscribing circle. Gross core area, how we got? Gross core area got 0.5 D square. 0.5 D square by pi r square. So if you solve this one, what you get here? 0.64. So this is for analysis of your square core. Square core means what you are going to find out? You are going to find out the gross core area, and you are going to find out the net iron area, and you are going to find out this ratio with respect to ratio of AI and area of circumscribing circle, and one more ratio you are going to find out. So these things we are going to use in this solving problem. That is what analysis of a square core section. Likewise, what we got, you have two-stepped core, also called as what? Also called as a cruciform core. If you see here, two-stepped means this is one. If you see here, this is one step. Here, this is one step. Okay, and this is another step. Okay, another one. Okay, this is why it is called as what? A two-stepped core. Okay, now take this part. If you take this part, okay, nothing but what? The width of largest stamping. The width of largest stamping is equal to A. Here, you can see it. This is the width A. Other side of the length is nothing but what your width, and this is nothing but your depth. I am considering only this part. This part. Okay, this is A and this is B. Likewise, if I take this section, this is A and this will be B. Almost both will be same. Here I'll written a little bit bigger size. Both will be same. Okay, this B and this B are same. Okay. Okay, this is A and this is B. Let us find out the gross core area for a two-stepped core. Now see here, the above figure shows two-stepped core or a cruciform core. Gross core area AJ. I'll take first this section. I'm going to take this section. Okay, this one. This section I'm going to take gross core area. Gross core area is something about what is A into B. Okay, this one. A into B. I written A into B. Next, I'll take gross core area of this section, the smaller one, this section. So this B is already included. This B is already included with respect to this section. So I want to minus this B. So I want to take gross core area of this section is nothing but what? I can write what? I can write this section I have to take. And now I got B here. I written B. I want what? I want this section. I want this section. The already B is included. This B distance is included with respect to the first part of the section is already included. So what I have to want? This B I want to minus. So I only want to calculate this portion from year to year and year to year. Since this portion is already included with this B portion is already included with this this section. What I written here A into B. So how do you find out this part year to year and then year to year? So I can find out what? A minus B. If I do A minus B, then what I got, this distance I got, this part and this part I will get it. So what I written here, B for this step for this this section B into A minus B. Then what I got, I'll get this distance and this two distance. I'll get it. Okay, B into A minus B. If you solve this one, then what you got? 2AB minus B square. 2AB minus B square. Once again, I'll repeat down. Each two-step core, we have two sections. We have two sections. This is one. This is one part of the section, and this is another part of the section. If you want to find out the AGA for our first part, this is nothing but what? The A into B. This is for this part. Okay, A into B. Then I have to find out the cross core area for this part. This part I have to find out. Then once again, I have to find out what? This is depth is nothing but B and width is nothing but A. Since this part is already included in previous section, this part B, the distance B is already included in previous section, I have to minus this one. How do I minus? I can minus A minus B. A minus B means only I get this two part, this small part I have to get it because it's already included. So B is equal to A minus B, and what I got 2AB minus B square. This AGA. Gross core area AGA is equal to 2AB minus B square. So what I have to calculate? I have to calculate this A and I have to calculate this B. If I know A and B, then I can calculate what? I can calculate AGA. So to calculate this A and B, you take this, so I've taken this part separately. I am shown here. This part I have taken. You see, I have shown it separately here. So this is the width of project stamping A, and this will be the depth. Width and depth of your laminations. Okay, depth of your one part of the core, A and B. So into here cos theta is nothing but what? Adjusted side by hypotenuse, A by D, and A is equal to D cos theta. Likewise, you do sin theta, opposite side by hypotenuse, B by D, and what is B here? B is equal to D sin theta. So gross core area AGA. AGA is nothing but what? 2AB minus B square. Substitute for A and B here. So 2D cos theta into D sin theta minus B square. Minus B square means D square sin square theta. So 2D square sin theta cos theta into D square sin square theta. D square into 2 sin theta cos theta can be written as sin 2 theta minus D square sin square theta. So D square into sin 2 theta minus sin square theta. That is equation 1. For this area, okay, for this area to be maximum, you have to differentiate with respect to theta. So for this area to be maximum, the gross area should be maximum. So you have to differentiate with respect to theta. If you differentiate with respect to theta, D AG by D theta, you differentiate here. So then what you got here? So D square, this concept you take it, D square, sin 2 theta, 2 cos 2 theta, and sin square theta. Sin square theta can be written as what? 2 sin theta cos theta. Okay, D square into 2 cos 2 theta minus sin 2 theta. So D is nothing but what? D is nothing but the diameter of what? Diameter of your circumscribing circle. What is D? Diameter of circumscribing circle. So that is a real thing. So distance cannot be equal to 0. So what you can equate? You can equate 2 cos 2 theta minus sin 2 theta equal to 0. So 2 cos 2 theta is equal to sin 2 theta. Sin by cos, you get tan 2 theta equal to 2. And 2 theta is equal to tan inverse of 2. So theta is equal to tan inverse of 2 by 2. Then you put the value of tan inverse of 2. Then what you get here? Theta is equal to 31 degree 45 minutes. Then for A. A is equal to D cos theta. Theta is nothing but 31 degree 45 minutes. Then what you got? A is equal to 0.85 D. And substitute for B. B is equal to D sin of 51 degree 41 minutes. Then what you get? 0.53 D. Then finally find out what? Gross core area, AGI, 2AB minus B square. Substitute these values, then what you get here? Finally what you get? 0.62 T square. So gross core area of two-step core. The gross core area of entire two-step core, what you got? AG is equal to 0.62 D square. Likewise, previously you have calculated what? Gross core area of the square core. What you got? Gross core area of square core, 0.5 D square. Likewise, here gross core area of two-step core, 0.62 D square. That is gross core area. So gross core area include along with iron pot, include the iron pot and also the insulation pot. Let us find out the net iron area, AI. Net iron area AI is equal to what? Ks into AGI. So what is Ks? Ks into AGI, 0.62 D square. What is Ks here? 0.9. 0.9 into 0.62, what you get here? 0.56 D square. You can see here net iron area without insulation, 0.56 D square. If you take gross core area AGI, what you got here? 0.62 T square. So the difference of 0.62 and 0.56, what will you get the difference? That is nothing for insulation. Okay. So these values are you are going to use with solving. Now ratio, once again find a ratio. Ratio is equal to net core area AI divided by area of circumscribing circle. So what AI got 0.56 D square by pi r square. If we solve this one, what we got 0.7. Likewise, to find out one more ratio, gross core area AGA divided by area of circumscribing circle. If you gross core area is 0.62 D square, if you solve this one, what you get 0.7. Okay. Likewise, you can do analysis for what? 3-step core I can do, then 4-step core I can do it. Then I have prepared a table here for square core, for cruciform core, for 3-step core, and for 4-step core. This is something the ratio. These are two ratio, and this is nothing but your AI, net iron area. These are the values. It is very useful for solving problem. Okay. That is regarding what analysis of a square core and 2-step core. They asked in the examination. 3-step core and 4-step core. They never asked. The analysis of the 3-step core and 4-step core is still difficult one and still lengthier one. So if they suppose if they ask analysis, they may ask with respect to square core or with respect to cruciform core. Okay. Okay. These things, these values we are going to use in the use while solving. Let's come. We'll go through some of the theory aspects like what should be the flux density, what should be the current density, what should be the window portion, what should be the area of window portion. All those things we will discuss. Now let us see now. Selection of the design constant. In that, first we take choice of flux density. So if you remember, if I go back to the go back to the derivation in there, if I go back to the derivation. Okay. If I go back to derivation, what is induced EMF here? Induced EMF is equal to what? 4.44 F5M. Phi m you can replace with what? You can replace with the Dm into AI. Dm into AI. Dm is nothing but flux density. AI is nothing but area of the core. What I have shown here, square core or cruciform core. AI represent what? Net iron area of the core. That is one. Also, if you go with the output equation, you can see this is output equation 2.22 F BMIAI. KWAW delta into 10 power minus 3 is nothing but what? Q represents what? U is nothing but your output equation. So even if you consider both output equation and EMF equation, where EMF equation, if you consider both the things, we can say that we can say that the voltage equation as well as output equation indicates that if we choose higher value of flux density, flux density, if I choose higher value, if you take this equation, okay, if I take this equation, okay, so Bm higher value of flux density. If I take this equation, Bm is equal to what? Q divided by the entire part A will come in denominator. So the maximum flux density is inversely proportional to AI. If I take a Bm or more, then what will happen? The net iron part of your core, the net area of iron area of your core will become less. When the net iron area will become less, definitely what you are going to use the material, the ferromagnetic material for the core part will become less. And around that core, if you want to do the winding, suppose if you take this core, so if Bm is large, Bm is equal to inverse proportional to your area. So if Bm is high, AI becomes small. Means what? Your net iron core area will become less. If net iron core area means the material used for this core, there's nothing but ferromagnetic material, will become less. And what you are going to do the winding around the core, that will the mean turn also will become less. So I can save the iron part. Also I can save what? I can save the conductor part. If I go for higher value of flux density, okay, higher value of flux density. Thus, there is a saving of the cost of iron and copper. So, if you go for a higher value of flux density, you have one disadvantages. As I told earlier in the previous classes, if you go for higher value of flux density, there will be what? There will be larger magnetizing current. If there is a larger magnetizing current, your core gets saturated. If your core gets saturated, then your output or efficiency will be decreased. Then it will be stopped. When the core gets saturated, there will be no more water, no more electromagnetic flux. So You can't go for even for higher value of electricity where the core saturates. So we have to operate the transformer within a certain amount of flux, certain amount of frequency. See that you can select in such a value that the area of the core, the iron part and the conductor part also get reduced, and the core should never go to saturation. Thinking these 2 points in the mind, we can select what? We can select the permissible value of electricity. What are the permissible value of electricity here? You can say for distribution transformer, I can go for 1.4 to 1.4 Vapor per meter square. If transformer is used for hard rolled silicon steel, okay, for power transformer, I can go for 1.2 to 1.5 Vapor per meter square. This is electricity for power transformer. For transformer using CRGO, means cold rolled green oriented. Okay, if they use this type of sheets, then the effectivity is for 1.5 to 1.7 Vapor per meter square. This is what the choice of flux density. Likewise, you have to go for what? You have to go for choice of current density. Current density is given by the formula what? Density is nothing but what? Current by area. Once again, the current density is inversely proportional to area. If you go for higher value of current density, then area get reduced. Area of the core get reduced. If area of the core get reduced, once again, what will happen? We can use little bit of iron part and one little bit of conductor part. If the current density is high, what is the disadvantages? If you go, that is one disadvantage. That is one advantages. If you go for higher value of current density, the area, the core area part will get reduced, so that I can save in iron part. I can save in conductor part. But if you go for higher value of electricity, higher value of current density, what will happen? The heating, there will be more heating, because higher value of current density means there will be more heating. Definitely the efficiency will come down. Why efficiency will come down? Efficiency will come down due to what? Due to there will be excessive temperature rise, and insulation may get damaged, and even the high square or loss. High square or loss will be. So once again, we can't go for higher value of current density. You see that efficiency and loss will be at efficiency will be maintained at a proper value, and even the loss will be maintained. Okay. Based on that, we have to select what? We have to select the current density. So likewise, for distribution transformer, for distribution and small power transformer, current density is 1.5 to 2.6 ampere per mm square. For medium and large power transformer, it lies between 5.4 to 6.3 ampere per mm square. Okay, this is regarding what? Regarding the choice of current density and the choice of your maximum flux density. Likewise, I will go for choice of window space factor. Window space factor, everyone knows nothing but what? KW is nothing but the conductor part in the window divided by the area of the window. Something conductor part of the window divided by the area of the window. Take this one. You can see here. KW is nothing but what? Conductor part. This is a conductor part. What is mean? Conductor part of the window. This is a conductor part divided by area of the window. That is called as what? Window space factor. Okay. KW. What would be the value of window space factor? We'll calculate. Okay. So KW is equal to 10 divided by 30 plus kilovolt, where kilovolt is a voltage of high voltage winding. Where this represent what? The voltage of high voltage, the voltage range of high voltage winding in terms of kilovolt. So KW is equal to 10 by 30 plus kVA. This is used for this formula is holds good for the transformers operating of what? 50 to 200 kVA. Likewise, KW is equal to 12 by 30 plus kVA for above 1000 kVA transformer, and KW is equal to 8 divided by 30 plus kVA for about 10 kVA transformer. Okay. Once again, the window space factor depends upon the rating of the transformer aligned with this formula. Next, choice of window dimensions. Choice of window dimension. What should be the window dimension? We know this window. Area of the window is nothing but what? Width of the window and height of the window. Area of the window is nothing but width of the window and the height of the window. Okay. Too narrow window. If a window is too narrow, if your window goes too narrow, then what will happen? The height of the window increases. Okay. If the window is too narrow, then the height of the window increases. The height of the window increases. Since in this case, the distance between the adjacent limbs. If the height of the window increases, if a window is too narrow, the height of the window increases, then the adjacent distance between the two limbs. This is what? Side limbs, and this is center limb. The adjacent distance between the two limbs, it decreases. Okay, it decreases. then definitely what will happen? The leakage reactance also reduces. The leakage reactance also reduces. If in contrary on other side, if the width of the window increases, if the width of the if this width of the window increases, then what will happen? The height of the window decreases. If the height of the window decreases, then if the height of the window decreases, definitely the adjacent the distance between the adjacent limbs also increases. Then what will happen? The leakage reactance also decreases, increases. Okay, so this will lead to increased leakage reactance. So thus, depending upon the suitability of the winding and desirability of leakage reactance, the height and the width of the window can be adjusted. What should be the height and the window? So the ratio of height of the window divided by the width of the window should be 2 to 4. Height of the window divided by width of the window is equal to 2 to 4. The most crucial value, what you are going to take? You are going to take 3. Height of the window divided by width of the window, you are going to take 3, and it lies between 2 to 4. That is what regarding the choice of window dimension. Once again, this we are going to use in the problem when they don't give height and when you're calculating height of the window and width of the window, we are going to use this relation for calculating in the problem. Next, width of the window for optimum output. This the width of the window for optimum. What is the here? Nothing but what width of the window for optimum output. It is given with formula D is equal to 1.70. The D is the distance between adjacent limbs as shown in the figure, and D is equal to 1.70. Here in AKSAN book we have derivation for this one. D is equal to 1.70. Since they are not asked, I have not done any derivation. Just we remember this formula. D is equal to 1.70, where D is the distance between adjacent limbs, and this small d is nothing but the diameter of your circumscribing circle. This is here D. What you are going to do the winding is nothing but what? The diameter of circumscribing circle. So the width of the window which gives the maximum output. The width of the window which gives the maximum output, I can write W is equal to D minus D. Capital D minus D. 1.7 D minus D, what do you get? 0.70. So the width of the window which gives the maximum output is W is equal to 0.7 D. Once again, this value will use our solving problem. That is regarding what? The width of the window for optimum output. Likewise, we will discuss regarding the yoke dimensions. What should be the yoke dimension? You can see here we have 3 different types of yokes here. This is nothing but yoke can be either what? Yoke cannot be what? Yoke cannot be a square. Yoke will be rectangular, and it may be 2-stepped or it may be 3-stepped. If you see here, with respect to this figure, okay, see. Yoke, this is a yoke part. So this is the height of the yoke and this is the depth of the yoke. This is nothing but yoke part. Yoke part always will be a rectangular. Yoke part from here to here always will be a rectangular, and it may be a rectangular or 2-stepped core or 3-stepped core. But core part, if you take only this part here, this is this part. This part is nothing but a core part. Core part can be a square, it can be a 2-stepped, it can be a 3-stepped, or it can be a 4-stepped. Okay. So we will discuss regarding regarding the yoke. The section of yoke can be either rectangular or it may be stepped, 2-stepped, or 3-stepped, or 4-stepped. In case of rectangular section yoke, the depth of the yoke means this is the depth of the yoke. You can see here, this is the height of the yoke, and this is the depth of the yoke. Depth of the yoke. The depth of the yoke is equal to what? The depth of the yoke will be equal to the depth of the core. Okay, if you go to the problem, see here. If you see this is what? Depth of the yoke. This entire thing is what? Entire thing is your yoke part. If you take only up to this part, if you take this line, you extend here, this part is nothing but your core part. Likewise here, from here to here, is core part. Yoke part will be entire thing here. Okay. So the depth of the depth. This is what? This is nothing but the height of the yoke. Height of the yoke, and this is depth of the yoke. The depth of the yoke will be equal to what? Equal to the depth of the core. You can see here. Depth of the depth of the yoke will be equal to depth of the core. Okay. If you take square core, even it will be what? It will be equal to the width of largest triangle. Square means both your width and depth will be same. Okay. Now AY is something about what? Area of the yoke. Area of the yoke means something about HY is something height of the yoke, and DY is something about depth of the yoke, is depth of the yoke. The area can be calculated. AO is nothing but what? Depth of the yoke into height of the yoke. Area of the yoke can be calculated as height of the yoke into depth of the yoke. This is there. Depth of the yoke is equal to depth of the core is equal to width of largest stamping. So normally, if you take if you take square core, depth of the yoke is equal to depth of the core is equal to width of largest stamping. Means square means both sides will be equal, A and A. If you take a two-step core, if you take a two-step core, okay, the depth of the yoke, A, the depth of the yoke, this is height of the yoke, this is height of the yoke, this is depth of the yoke. This is nothing but you can see here, two-step core. This is depth of the yoke. Depth of the yoke will be equal to what? Equal to depth of the core. Depth of the yoke will be equal to depth of the core, or it equal to what? It equal to the width of largest stamping. Okay. If you see from the top view, what you'll get this figure if you see from top view. So the depth of the yoke will be equal to the depth of the core, and depth of the core is nothing but what? Width of largest. Okay, width of largest stamping. So what do you get here? dy is equal to what? Dy is equal to a width of largest core stamping. So ay is equal to what? 1.15 to 1.25 of AGI for transformer using for hot rolled steel. And this is nothing but your AY is equal to AGI for transformer using the grain oriented steel. So rarely we are going to use this for one normally. If I want to find out the area of the yoke, nothing but what? Depth of the yoke into height of the yoke. These are the figures you can see here. You can see here. This is nothing but what? The two-step core or cruciform core. If you see from top side, okay. This is side view. If you see from top side, what you see? You see like this way. Okay. You see from top side, you can see what? You can see this figure. If I remove this part, actually it is you see top view. I want to see the winding. This core is above this winding, but I want to see the winding. Then I can see what? I can see like this. If I remove this part, from here to here, if I remove, I can see what? I can see here. Here I showing data line. I removed it, so I can clearly see what? I can clearly see the cruciform core or two-step core. Cruciform core or two-step core. I can clearly see it. Okay, that is likewise. You will have what? You will have three-step core and you have four-step core. Okay. That is regarding what? Regarding the types of yoke and the formula related to the yoke. Okay, what I explained, same thing. See here, the depth of the yoke here, you can see here. From here, depth of the yoke will be what? Equal to depth of the core, and depth of the core will be equal to width of largest stamping. Width of largest stamping means nothing but what this one. This is the width of largest stamping, that will be equal to A. Okay. That is regarding what? That is regarding the yoke part with the different types of yoke. Whether you may go for rectangular yoke or a two-step yoke, two-step core, or you can go for a three-step core. Okay, that's regarding this one. And next, we will go for overall dimensions. Overall dimensions, I think overall dimensions of the transformer, seeing from the top view and seeing from the side view. This is nothing but your top view, and this is nothing but your front view when you cut the transformer. So when this is transformer, if you cut the transformer, when you cut this transformer, we are going to see the front view. Section we are going to see the front view, and this is nothing but your top view. Top view nothing but see from the top view. See from the top what you got. We are going to see this one. For simplicity, we have removed these things and we are written in dotted line. We are written in dotted line, and this is the top view, and this is your front view or what your front view. Okay, when you cut the transformer. Okay, seeing that, I'll try to come up with a relation of different types of transformer. Okay, overall dimensions. A is what? A is nothing but width of largest stamping. D is nothing but diameter of circumscribing circle. D is nothing but distance between the center of adjacent limbs. WW is width of the window. HW is height of the window. Height of the window is nothing but even length of the limb. Height of the window. This is height of the window. Is nothing but what? Length of your limb also. Length of the limb. Okay. H, overall height of the transformer. Overall height of this is H. Overall height of the transformer. W, overall length of the frame or overall length of the yoke. This is W. Here you can see this is W. This is W. Overall length of the yoke or overall length of the frame. This is nothing but overall height of the transformer or overall height of the frame. H. Okay. These are the things, and we try to relate these parameters. Now come to single phase core type transformer. This is nothing but what? A single phase core type transformer. Come here. For single phase core type transformer, what is D? Say D here. D, what I told D is nothing but distance to the center of adjacent limbs. This is D here. You can see here, this is D. This is nothing but what? I have taken from the center of this limb and to this limb. I have to calculate this D. Okay. How can you calculate this D now? D is equal to width of the window here, WW, width of the window, plus this is what? This D is nothing but what? The diameter of circumference circle. This is a D, diameter of circumference circle. Okay. So I want up to here D. So I can take here half D. I can take half D here, half D. Then what I get full D. Okay, D is equal to WW plus D. I want D. So WW width of window plus half D, I'll get full D. Next, depth of the yoke. I require depth of the yoke. Depth of the yoke means I go for three-dimensional view. Depth of the yoke. Since it is two-step, depth of the yoke. This is the depth of the yoke. Depth of the yoke will be equal to depth of the core or depth of the largest stamping. What is the depth of the largest stamping here? Width of the largest stamping. Depth of the yoke will be equal to the depth of the core. That will be equal to the width of largest stamping. What is the width of largest stamping for two-step core? The width of largest stamping for two-step core will be equal to what? Equal to A. Either go if this represents what? This represents the depth and this represents the width. Both will be same. And this depth of the core here will be equal to even the depth of the yoke also. Okay. So depth of the yoke will be what? Width of largest stamping. So dy is equal to A. dy is equal to A. Next part, H, overall H. How do you calculate overall H now? HW plus here on HY, height of the yoke, here on is the top height of the yoke, it is bottom height of the yoke. Overall H is equal to what? HW plus 2HY. HW plus 2HY. And what is W? I want W. Overall, what is W? Overall width of the what? Length of the yoke or overall length of the frame. This W. I want this W. Overall length of the yoke or overall length of the frame. So W is equal to what? D. I want this W. So I got D here. I got D here. Then here, this A is nothing but what? Nothing but the area of your core. This A is nothing but the area of the core or width of largest stamping. Width of largest stamping. So I want W means I can get D here. I can get D. This D. And exactly this is at the center of the adjacent of the limbs. So I can get here half A and I can get here half A. So half A will become full A plus I can get what? WW. So I can get what now? W is equal to D plus half A plus half A. Then what I get the overall length of the yoke or overall length of the frame. So W is equal to D plus A. This is D. This is half A. This is half A. So D plus A. This is for what? A single phase core type transformer. Likewise, I'll go for a three phase core type transformer. Once again, D, capital D, you can come here. Capital D is equal to same thing. It will be capital D is equal to what? WW plus D. What it did for same thing. Capital D is equal to WW plus D and dy is equal to A. That remains same. H also remains same. H is equal to what? HW plus 2HY. But W, if I want overall length here, W, overall length W. Then what I can calculate? I can calculate this D plus this D, what we get 2D, 2D plus here half A, here half A and here half A. What we get? 2D plus A. So you can check here, this part don't consider this part. If you take the core part, this part is left normal, left free, it will be used as even for ventilation also, this part. So from ear to ear, it will be W. W is equal to 2D plus half A plus half A. Then what you get? 2D plus A. This is for what? Three phase core type transformer. Next, finally, we'll go for a single phase cell type transformer. If you have seen cell type transformer, the winding will be done. The winding will be done at central lane, and the width of the central lane will be twice of the width of the side lanes. This is the width of side lanes. Okay, and the central lane the width will be 2A. It will be twice of the side lanes, and the depth here depth will be what? Depth will be represented by D. Okay. Now, for a single phase shell type transformer dy, depth of the yoke. Depth of the yoke means once again for shell type, depth of the yoke will be what? Okay, for shell type, if you go back to shell type, suppose if you consider this as shell type, depth of the yoke will be what? Will be B. Will be what? Will be B. Because this is your this is 2 year represent what? 2 year represent the width, and this part you can come here. This 2 year represent width, and here this part represent depth. There is nothing but here B. This part represent depth. This part represent depth, and this part represent width. So even depth of the yoke will be what? Equal to B. Equal to B. So dy is equal to B. Height of the yoke. Height of the yoke will be what here? Height of the yoke will be, this is height of the yoke. Height of the yoke will be A. Height of the yoke will be A. What is W? Overall W. What is W here? Overall W. I can take here WW, WW, 2WW plus 2A plus A and A. So what I get? 2WW plus 4A. 2WW plus A plus 2A plus A, I'll get 4A. And overall height is what? H is equal to HW plus A plus A. So HW plus 2A. So these are all how do you going to relate this height of the yoke, depth of the yoke with this top view, and with this front view. How do you going to relate the diameter, height, window? Okay. Okay, this formula is used. It is very useful with solving problem. Okay, with this I'll end my class.